Hi, in the previous video, we did vector addition. Now we will take it forward and solve some numericals. The first numerical is up here on the board. Particle is at point O. It moves 12 meters due east, and so this is meters, not kilometer. This is meters. 12 meter due east. 5 meter due north. 5 meter due north. And then 6 meter vertically upward. 6 meter vertically upward. A to B, 6 meter. Find the magnitude of the sum of these displacements. Now I think I will show this in 3 dimensions. That will be better. So I have shown the 3 axes. Our origin is here. The point starts from O. The point starts from O. So our object is at O. It moves 12 meters due east. 12 meters due east. 5 meters due north. This is north. 5 meters due north. And 6 meter vertically. I have not shown it properly. 6 meter vertically. Now we have to find the displacement. Now this is the polygon law of vector addition. As you can see, the vectors are arranged end to end. So we have the first vector OA. Now the second vector begins where OA ends. Third vector begins where AB ends. Okay. So a vector begins where the previous vector has ended. So we follow the polygon law of vector addition. Okay, as we see here, the vectors are arranged end to end. So now we join the initial point O with the final point C to obtain the resultant vector. So resultant vector, I will show it in a different color, will be O to C. So my OC is the resultant vector. Okay. So OC is the resultant vector. Now OC bar. So OC bar is from the polygon law of vector addition. It is OA bar plus AB bar plus BC bar. Right. Now OA bar, now we have to add this. You see, if we want the magnitude. If you see, OA and AB are at right angles. Okay, OA bar is perpendicular to AB bar, because these are x axis, y axis and z axis. Now this angle is 90 degrees. 90 degrees. So we join vectors O and B. We join points O and B. So vector OB bar. I think I should show in a different color once again. Okay. So vector OB bar is OA bar plus AB bar. Okay. So we get from Pythagoras theorem OB square is equal to OA square plus AB square. Now OB is the magnitude of vector OB. Now what is OB square? What is OA square? 12 square. So 12 square plus 5 square. So therefore we get, therefore OB square is equal to 169, or OB, which is magnitude of vector OB, is root of 169, which is 13 meters per second. Correct? Now that's OB bar. Now that's not the final displacement. Correct? The final displacement is OC. Now if you examine closely, vector BC is vertical. So which means vector BC is perpendicular to this plane, to the xy plane, x, y. Correct? So vector BC is perpendicular to the xy plane. So we see that vector BC is perpendicular to vector OB bar. Yeah, we show it like this. Now therefore, now in this triangle OBC, in triangle OBC, when you see OC is the hypotenuse, so OC square, therefore OC square is equal to OB square plus BC square. So that's equal to 13 square plus 6 square. BC is 6. Now I will repeat, when I say OB, it is magnitude of OB bar, and as BC, it is magnitude of BC bar. So this is 169 plus 36. That's equal to 169 plus 36. That's equal to 205. Okay. So now therefore OC equal to magnitude of OC bar is root of 205. Now we can use the calculator and determine. So this is equal to 14.32 meters. Our answer. So that's the answer, 14.32 meters. That is the displacement of the particle. Correct. Now let us just go through this problem once again and see what are the key steps we took. Now first is, whenever you have a problem like this, first thing is you should make an illustration. Okay, first thing. So step number 1, make an illustration, because as they say, a picture is worth 1,000 words. So first step, always make illustration. Make an illustration. Now second step, once you made the illustration, now you can see it's quite easy. It's there, we can see these vectors OA and AB are perpendicular. Then the resultant of OA and AB is OB, and OB is perpendicular to BC. And why is OB perpendicular to BC? Because BC, as you can see, is along the Z axis. BC is along the Z axis, and Z axis is perpendicular to x and y axis. Correct? So it is simple Pythagoras theorem. We first find OB, then we find the resultant of OB and BC to get OC. Yeah. So our first step was making an illustration. Second step was we found resultant of OA plus AB. Find OB bar is equal to OA bar and finally in the third step we find that our final displacement, okay, OC is the sum of OB and BC, both of which are perpendicular, right? Then OC bar is equal to OB bar plus BC bar. Okay, these are our steps. There are steps. Okay, now this is the second problem. Two forces P and 2P, Newtons act on a particle. Now they are acting on a particle. Now this has a meaning. What it means is that these forces have a common start point. So if P is acting in this direction, let me check the color. If P is acting in this direction, P, then P is here. Alright, then 2P will start from the same point because they are acting on the same particle. You see, P and 2P are acting on a particle. It means they have a common start point. Both of them, they start from the same point. So P is here, so 2P will be like this. 2P. So now we know that we are going to use the parallelogram law of vector addition. So let's complete the parallelogram and we label the points. So this is point A, B and C. Now we complete the parallelogram. Okay, point D. Now the resultant is obtained by joining the initial point with the final point, A with D. So AD is the resultant, correct? So when two forces P and 2P act, the resultant is AD. Okay, so AD bar is equal to AB bar plus AC bar. Yeah, all right. Now suppose the problem says that you double the first force, so P becomes 2P and the AC becomes 2P plus 20. Now the direction of the resultant does not change. Now we have to do a little bit of analysis. All right, so let us see if the angle between the two vectors AB and AC is theta. All right, so then now this is the formula you will have to remember. Now then the resultant vector, okay, AD bar, magnitude of AD bar, AD equal to magnitude of AD bar, and that is given by square root of AB square plus AC square plus 2 times AB into AC into cos theta. Okay, so let me make some correction here. I think I should remove the A from here. this square root sign comes to here. I'll write a here. Okay, now this is the formula for obtaining magnitude of resultant vector. Okay, now the direction of the resultant vector, direction of AD. Okay, let us say we give the direction by angle alpha. Okay, direction of AD is given by angle alpha. So angle alpha can be obtained as tan alpha. So direction of AD is given by tan alpha. That's equal to 2p, or 1 second, AC sin theta upon AB plus AC cos theta. So this formula, the first formula, AD equal to root of AB square plus AC square plus 2AB AC cos theta, this gives the magnitude of the resultant, and this gives the direction of the resultant. Correct? Okay, if AB becomes so we have seen that, we found the magnitude and the direction. When we say direction, it is tan alpha. So we have magnitude of resultant, we have direction of resultant. Correct? Now the problem says that AB is made twice, so AB becomes 2 times of AB, and AC becomes AC plus 20, 2P plus 20. So now we have AB becoming 2 times of P and AC becomes 2P plus 20. So again we complete the parallelogram, the first step. The resultant is obtained by joining the start point, initial point and the final point, A and D. Now the problem says that when you do this, when you make AB 2 times of P and when you make AC 2P plus 20, the resultant will change, but the direction does not change, which means the direction remains alpha. It remains alpha. Okay. So now we will say, once again we will say tan alpha, therefore tan alpha is equal to 2P plus 20, 2P plus 20 sin theta upon 2P plus 2P plus 20 cos theta. Now this direction is the same as the direction obtained above. It is the same as this direction. Okay, these two are same. This and this are same. Okay, so let's equate. Let's equate. To find the value of P, let's equate. Let's say, so this is equal to, so therefore 2P plus 20 sin theta is equal to 2p plus 2p plus 20 cos theta. Now these are equal to the first result was 2p sin theta upon p plus 2p cos theta. So the sin theta will cancel. Okay, sin theta will cancel. So now we have therefore 2p plus 20 upon two p plus 20 cos theta is equal to 2p upon p plus 2p cos theta. Okay, now I think we can cancel 2 here. So this becomes p plus 10, correct? You take 2 common, it becomes 2 into p plus 10, so 2 will cancel, p plus 10, correct? Now let's cross multiply because we have to solve for p. So we cross multiply these two with these two. Okay, so p plus 10 into p plus 2p cos theta. So p into is equal to p into 2p plus 2p plus 20 cos theta. All right, so let's open the brackets. What do we get? So therefore p square plus 2p square cos theta plus 10p correct. That's equal to 2p square plus 2p square cos theta this 2p square will cancel with this 2p square cos theta, this should be cos theta. 2p, so 2p square cos theta will cancel this 2p square cos theta. 20p cos theta will cancel with this 20p cos theta. So we have p square plus 10p equal to 2p square. So p square minus 10p is equal to 0. Therefore, p into p minus 10 Therefore, p equal to 0. That's the answer. Okay. Okay. With this we will end this video, and the next video we will see vector multiplication. Until then, I wish you good night, but not before reminding you to call on 98702 15815 or call on 98702 15815. Okay. Okay, we end the tutorial now.